Hi. So let's very quickly, in a few minutes, 3-4 minutes max, talk about, let's say, different kinds of losses, or the two most important kinds of losses. So we have looked at cross entropy in a lot of detail. We've actually implemented it, both the forward and the backward. But then let's also talk about the very simple loss, right? The L2 loss. And you know what the L2 loss is? It's essentially your output minus target, the whole square, under root, right? And sometimes you can just forget about the under root and then you can call it, let's say, the L2 squared loss, right? So the square of the L2 loss. And L2 loss is the Euclidean loss. So what does it mean, right? So if your output vector is of size this, right? So if it's a vector, then you want to take this. So then it becomes, let's say, O1, O2, and T1, T2. Then what does it become? It becomes O1 minus T1 the whole square plus O2 minus T2 the whole square, and then you can have the under root, but you can also ignore the under root because then you can just call it the square of the L2 loss. So when should you use the L2 loss and when should you use the cross entropy loss? It's very simple. When it is about, let's say, hitting a physical target, right? When it's about, let's say, doing this so-called regression, when it's about predicting prices, predicting temperature, predicting speed, when we want the physical quantity as a number as close as possible, when it's not a classification problem, when so it measures the distance because it's the L2 distance. When we really want to hit a physical target, when we really want to hit a point, that is when we use L2 loss, right? And the logic is, if you hit the bullseye at 100 but you're at 90, you're still this 10 units away. And if you hit 50, then you're 50 units away, right? So there is a physical notion to this distance. Now, when we want to do, let's say, classification, we use cross entropy. And how this works is, it's a measure of surprise and confidence. Meaning, if the answer is A and you say I'm 99% sure it's B, you're not just wrong, you're confidently wrong, right? And cross entropy gives you a massive penalty for this arrogance. But and the goal here is to maximize the probability of the correct class, and it's best for a classification problem such as spam versus not spam, cat versus dog, etc. And you remember, it's basically the negative log of the probability of the correct class, right? So let's say our second class was correct and we got a, let's say, 0.1 here, so we want to give it a massive loss, right? Let's say our one hot vector, the target, this was the output, this was the target, and output is essentially the p's, right, which is after the softmax, and this is our targets, and the targets was 0, 1 and 0. So it's essentially, if you are, let's say, the correct class is, so we got like a high penalty because for the correct class we got a very low score, and let's say here we got, let's say, 0.8 and or let's say 0.85 and 0.05 here, right? So here, let's say this was, so whatever is the probability of the correct class is what we want to minimize, right? So if you get a very low score for that correct class, you want to give it a massive penalty and say, shout wrong, right? So that is what cross entropy will do. Another intuitive way to think about it is, it's like if you're teaching the child, which is, let's say, the model, with cross entropy, if the child confidently gives you the wrong answer, you shout wrong, right? High gradient, and the child learn immediately. But with MSE, if your child confidently gives you the wrong answer, but you say, you are technically 1.0 units away. So you get a low gradient. So you can use, let's say, MSE loss, the L2 loss for cross entropy, but the training will be very slow because you're just saying, okay, you're just 1.0 away. And what is the result? The model barely changes its mind because the penalty feels too small. It learns extremely slowly. So summary, what you want to remember, the rule of thumb is, if you're predicting how much, you use MSE, the mean square error, and if you're predicting which one, you use the cross entropy error. Straightforward.